Good evening, all. I welcome you all to our fifth day of PULMOCON 2021 session, and I welcome everyone to today's session. I hope it would be an interesting one, and I would like to request our organizing secretary, Dr. Parthasarathi Bhattacharya, to kindly proceed over the session. Sir, over to you.
Thank you very much. I am really delighted to welcome you all to our fifth module. This is an exceptional situation, exceptional module where there's no medicine, but there's a lot more and much more interesting events. So I'm very lucky and fortunate that I've got two great speakers for today's session, both from ISRO, and they will be rightly introduced by my chairperson. My job is to introduce my chair, who is Dr. Shantanu Bhowmik. He is a professor at the Department of Aerospace Engineering at School of Engineering Amrita Vishwa Vidyapeetham, and is also an adjunct professor for the Center of Future Materials, University of Southern Queensland, Australia. Dr. Shantanu has got a lot of awards and laurels. I'm not going to list them. And he has got a lot of researches, more than 100 papers. And right now under him, there are 8 PhD scholars working. He has got 24 sponsored projects running under him right now. In between, he was very instrumental to set up a nanotechnology and applied adhesion center, international center at Sikkim Manipal University, Sikkim. Why Dr. Bhowmik is so apt and so adored is because of his innovations. These innovations of indigenous technologies are of immense value, and I have just listed a few of them. We might have come across from Lay newspaper about the lightweight bulletproof jacket prepared in India, lightweight rust-proof composite, lightweight hybrid composite container for storage of nuclear wastes, recycling of plastics. He came to my institute once and given a very illuminating lecture. We find a lot of people talking big things about translation of knowledge to practice, but most of them are cacophony. We don't find a real product, but he is one exception who brought a real product in his hand and showed us. And he sent me a video where his plastics do not get fired. Even they have been soaked in petrol, and then the matchstick is put on it, light. It didn't catch fire. So it is really a wonderful experience to see such wonderful innovations. This very scientist is known to me, and I have got, because I know him personally by now, there is a bias. There is many more qualities with him beyond his scientific acumen. He's a poet and he's a good artist as well. You can see his picture and a book on poetry, Shopno Alod Deshe, in the land of light of dreams. So with this brief introduction, I requested Dr. Bhowmik to take over. And before that, I have got a pleasant duty to request him. We are a very small institute. We have been obliged by the grace been shown to us by our two faculty members today. I would request Dr. Bhowmik to introduce these two speakers and also to confer a small token of memento to them in the course. So with this, Dr. Bhowmik, please.
Thank you, Dr. Parthasarathi. It was a great privilege that I came to know you, and also now my job has started. It's a great start you have done. So Dr. S. Rakesh, whom I know since 2013, when he was the Deputy Director of Vikram Sarabhai Space Center, he is I would say not only a great scientist, but is a very highest, I would say, level of human being, which really means a lot for that. He is a distinguished scientist in space science and currently Chairman and Managing Director of Antrix Corporation. He was the Director of ISRO's Propulsion Complex, and also he was heading that Vikram Sarabhai Space Center Composite Entity 2011-2015. He is the recipient of ISRO Team Award 2011 and Merit Award 2012. He has written several articles on Indian space and teaming with the PwC, has published a position paper that Indian space sector. He is an avid naturalist and a life member of BHNS, and also is a nature lover. So I have a very good friendship also in that. He's a very great nature lover. And I'm pretty sure that his presentation will be a unique one. It will be really motivating to all. And as a person, I respect him, and I really respect also his patriotism. That also very mattered to me, and as well. And I think Dr. S. Rakesh, and then I'll be starting Dr. Unnikrishnan Nair. So kindly go to the next slide. Yeah, so this memento from the ISRO Pulmocare, it has been given as a memento. I think that naturally once you'll be coming to Kolkata, Dr. Parthasari is so generous. Okay, he'll be hosting, and the special lecture will be attended and arranged there. And he'll be liking the institute also and their work culture as a team. So this memento we confer to Dr. Rakesh from the Institute Pulmocare, and so kindly you accept that memento, Dr. Rakesh. So
thank you for that memento. It has been an honor to receive such a memento from you, Dr. Parthasarathi. Thank you very much.
So
it was my ardent, it was my desire to get you to Kolkata, both of you, in fact. Because of COVID, we couldn't do it. We'll definitely keep this option open for future, and you have to know.
Sure. Definitely.
Okay. So now I introduced that second speaker, that Dr. Unnikrishnan Nair, now presently director of the Human Space Flight Center, ISRO, Bangalore, India. He's serving ISRO since 1985, when even I was a school student, Dr. Unnikrishnan. Okay, so you are much senior to us. So he's having a PhD in mechanical engineering and professional experience in advanced space transportation and the space acoustic, production system, aerospace mechanism, re-entry and recovery technologies for the human space flight. He has got number of awards, that ISRO Team Excellence Award for contribution to space capsule re-entry experiment in 2007. ISRO Excellent Award twice as team leader for Crew Module Atmospheric Re-entry Experiment in 2014 and Crew Escape System Pad Aborts Test in 2018. ISRO Individual Merit Award in 2014 for contributions towards technology development for manned space mission. Honorary doctorate in 2019 for an outstanding contribution to human spaceflight activities and other activities, that co-authored and edited the book for International Academy of Astronautics, co-edited the special issue for Journal of Aerospace Science and Technology, authored several papers, including 12 international journals and conference papers, and certainly that like India is heading towards the manned space mission. So we really overwhelmed that that knowledge will be transformed to know everyone. And I'm sure that with your lecture, the many technological innovation will come. So many young minds are joining in this program. So once again, on behalf of ISRO Pulmocare and the director, Dr. Parthasarathi, this memento is conferred to you. So kindly accept the memento. And also, if you come to Kolkata, you will have a direct interaction with the students and the faculties there. So kindly take this memento, Dr. Unnikrishnan.
Thank you for your nice words. And with all humility, I accept the memento. Yeah, we would have loved to come to Kolkata. Maybe we will do it soon when the situation is now coming back to normalcy. Thank you for these kind words and this moment.
Thank you, sir.
So now we'll be going to the technical session. So the first speaker is Dr. Rakesh Sashibhushan. So he will be giving the in-depth knowledge. He will be spreading the knowledge with the satellite technology. And presently, since he is the managing director and chairman of Antrix Corporation, and you know that satellite does a lot of things for us. The communication, it gives the weather prediction. Even the spy satellite can zoom that the border, and even our networking, like you see the computer, television. So a lot of applications satellites. So many technologies will be evolving also in this lecture. And once Dr. Rakesh will be completing this lecture, second will be Dr. Unnikrishnan, and then we'll be going for the question and answer sessions. So kindly, Dr. Rakesh, take your presentation and give us the complete knowledge about satellite technology.
Yeah, thank you, Shantanu. One small clarification. I'm not going into too much technology in this particular presentation because this is a very wide audience. And I thought I'll give a brief introduction. Of course, we can discuss, that is a different issue. And maybe another opportunity in a technical forum, we can go in depth. That's just, I wanted to give an exposure to various satellite technologies and where it is going. So that, it will be a precursor to the talk that Unnikrishnan will be delivering, the main talk Unnikrishnan is delivering. So I think I will share my screen. So the screen is visible to you?
It is visible, yes. I think you can make it full screen.
Okay.
You may kindly make a full screen.
Yeah,
it's fine, absolutely fine. Yeah.
Okay, fine. So I thought I will give, see, the satellite technology today is going through a transformation, especially in many spheres like communication, where the traditional concepts are being challenged, and the satellite technology is poised to get into the lives of each and every one of us in one form or the other. And we are living in a world driven by technology. And tomorrow, all these technologies, various technologies, the terrestrial technologies, the satellite technologies, all are going to come together to define a new paradigm for us to work, and also to make our life much easier, and the processes that we are engaging in much, much more efficient and cost effective. So with this background, I just wanted to just get into the various satellite technologies and its applications just very briefly, and the new technologies that are on the horizon. So before I move, some history. As you may be aware, the first satellite, artificial satellite, was Sputnik 1. I have also demonstrated them in I put the photo of Sputnik 1 on the right side. That was nothing but a 600 diameter polished metal ball with some transmitter inside, and it was just testing out whether we will be able to receive the signals which is transmitted from space. And just imagine, it was launched in 1957 by USSR, and that created such a big furore in the world, especially in the US, as what these Russians are going to do. And it created probably the space revolution, or the space war, or the space race, as it is more often called. And that led to the development of a lot of technologies which benefited in many areas that we are engaged in now. The first person in space, you are all aware, Yuri Gagarin, 1961, and the first communication satellite, Telstar 1, launched by US in 1962. First launch by ESA was in 1979, and the International Space Station actually was launched in 1998 as a collaborative mission between various spacefaring nations. India's first satellite was Aryabhatta in 1975, and India's first communication satellite was INSAT 1A in 1982, which had developed some some problems in the orbit, and then it was followed up with INSAT 1B in the very next year, 1983. And at that point of time, 1983, there were very few players in the world itself. You had probably Intelsat and Inmarsat, and very, very few players like that. So India has a very long history, and definitely one of the major nations in the space, with all the technologies under its belt. And Unnikrishnan will be briefing on those things much better. I thought I'll start with a small video, which is that of PSLV World Record launch, where we launched 104 satellites. That world record stood until recently, when it was broken by a SpaceX launch. But yeah, just to set the tone, and just to understand how the world sees our launches. So I'll just hold it there. This launch took place in 2017, and this is a company who is rejoicing along with the PSLV launch. That is, they are the company called Planet in the US. They were having real trouble in launching their satellites and starting their operations, and they wanted to launch 88 satellites in PSLV. Prior to this, they had launched 36 satellites or they tried to launch 36 in Soyuz. And for some reason, those satellites could not be put into the proper orbit. And the company was going down. And if the launch of these 88 satellites was a make or break situation for this company. Okay, so we were doing a lot of launches for foreign companies and have been successful in providing these launches. And this was one of a very significant event because I still remember this team coming to Sriharikota and doing a Ganesha Puja because they asked around, about the success was very, very crucial for the company. Otherwise, the company would have closed down. Now the company is doing very well with more than 150 satellites, and for there in the remote sensing arena. And okay, now we will just look at various applications. One is, of course, communications. And when you watch your TV, probably when you use your mobile phone, and when you use your ATM and things like that, background, a satellite is working for you. It is in communicating the data. In case of the mobile, the data backhaul is done by satellites to the data center. And when you use ATMs, etc., from remote areas, probably the connection is being made through a satellite link. So these are some of the things that we use daily, and the satellite communication is touching our lives without probably the knowledge itself. And for Tata Sky, all the transponders are provided by the INSAT series of satellites. Remote sensing, as Shantanu was briefly mentioning, is a very, very important application for various arenas, including agriculture, resource mapping, water resource management, disaster management, and name it. Geospatial technology is there for taking the application to a different level altogether. I will touch upon some of the applications when we move forward. And GNSS, you are all aware when you use the positioning services in your using your application in your mobile or in your laptop. So this is being provided by various satellites. GPS is the satellite system that US uses, and India has its own satellite system called NAVIC, which is having it's a 7-satellite system. It's a regional system which is providing 1,500 kilometers beyond our borders, and that system is also now available in most of the mobile phones, and you can choose whatever system that you want to use when you use these applications. And in DTH, and both DTH as well as cable TV, both of them uses the satellite services for broadcasting and also for your reaching to your home. In the case of cable TV, the multi-system operators receive the signals from the broadcasting satellite, and then via cable it is fed to different homes. And in DTH, using satellite, it is broadcast, and with a TV dish you pick it up. So this communication was enabled in India in 2003 through the INSAT series of satellites, and now it has penetrated almost all homes in India. And moving forward, it is one of the biggest revenue earners, as well as far as this the satellite revenue stream, satellite business is concerned. Another big application is the VSAT, that is for connecting the corporates. The ATM services, as I was mentioning earlier, uses these kind of services for connecting the various the centers of the corporate or for the services. And you have this service in being vastly used in India in the connecting the rural areas, connecting the islands, remote islands, etc. And this is a very important service where many companies have got thousands of VSATs installed all over India. There are many service providers who have thousands of VSAT terminals. And this service is looking very strong because India is a country which is having more than 7,000 kilometers of coastline and many islands, both the Lakshadweep island groups as well as the Andaman Nicobar Islands. And also the geographical terrain of India demands connection in very, very remote locations, whether it is Northeast, whether it is Ladakh, or whether other areas also where reaching cable is very difficult. Satellite plays very important role in connectivity. And in disaster, when a disaster strikes, when all your land connectivity goes, then you can have satellite phones, which again directly connects to satellite, and then you can get connectivity to various applications. Another application for communication, satellite communication, is the digital satellite news gathering, or DSNG, which uses satellite dish in mobile vans for transmitting a live event to the satellite and then broadcast to the news center, which can collate it with other programs and then transmit it back through any MSOs or through DTH to the home. So this is another service that is being provided through satellite communication. So this is another view of the DSNG service, how it is provided. So with the graphics showing how the satellite is connected and how the signal travels to and fro to provide the communication. Internet of Things is an evolving technology, which is again comes under the satellite communication. And here, immense possibilities in connecting various machinery and using machine language connecting and enables automatic operation, the collection of the status of the equipments, and also in areas like precision farming, Internet of Things technology is used to control various farm equipments to deliver the correct amount of water as well as the fertilizers, so that it is accurately controlled, and in a larger area this can be managed through Internet of Things. So this is another application which is emerging in India also. This can be done. This is already being done by many corporates using terrestrial connectivity, but satellite has got a large role to play when you want to have connectivity across the country or across the world, where it has a very important role to play. And you will be hearing more about this IoT in the coming years. So this is, like I said, the precision farming is one of the major applications that is envisaged using this Internet of Things, where automated steering systems, variable rate technologies, integrated electronic communication, high precision positioning systems, all are integrated to control the farming and get the maximum yield out of this in large farms using this communication technology. In-flight connectivity and maritime connectivity are again the recent applications of communication, where a receiver receives satellite signals, a receiver in the aircraft, and then transmit inside the aircraft for internet connectivity. Probably some of you would have used it already. And in India, a couple of years back, it was enabled. And there are many companies which is providing both maritime and in-flight connectivity in India also. So this is just a pictorial representation of how it is done. The satellite connectivity using using satellites. And satellite broadband, again, a new application, because giving broadband through satellites was always an issue, because the bandwidth available through the conventional satellite bands was a little bit narrow, which didn't give you enough bandwidth for a broadband operation. And now, these services are available using various types of satellites, both the GEO as well as the LEO, the upcoming LEO systems, what Starlink and OneWeb kind of companies are offering. So these companies are rewriting the traditional concept of communication. And as you may be aware, the satellites that currently provide communication normally are in the geostationary orbit, which means that their orbital period is about 24 hours. So when the globe rotates, the satellite also rotates along with it. The satellite is always seen above the area where the service is to be provided, and that helps in the communication. But now this is being seen as a global service, and when satellite to satellite communication, etc., the new technologies have come in. People like the companies like Starlink, like OneWeb, etc., have come in and then putting thousands of satellites over the earth, and this is how it will look like, and then providing global connectivity, which will also have low latency, because if you have a geostationary satellite, which is about 36,000 kilometers above Earth, the signal takes about probably more than 0.5 seconds, 0.5 to 1 second for the to and fro travel, and that will have an effect on live operations actually. So, for example, you might have experienced the operation of drones in various wars actually. So these drones, once it goes outside the communication range of the ground station or the ship from which it is it has gone, then it needs satellite communication to establish the connectivity and receive commands, and also send back various kind of information, including reconnaissance. So these kind of issues can be better managed using such a system where the latency is brought down to probably about 30 to 50 milliseconds. So these kind of satellite systems will enable a drone operation in a real war situation, probably even on a live operation may be possible in the future. So this is a thing that is coming now. In India, it is yet to come. So you might have read in papers that these people have applied and some kind of licensing is going to come. And we are all waiting to see the policies and how this will come, and what will be the pricing and what kind of impact it will make in the current operations of satellite. We have a very traditional operation of satellite systems. So this technology will have an impact, and let us see how it will come and what kind of changes it will make in the Indian consumer scenario. Coming to remote sensing, and as you all know, when you say remote sensing, mostly we say passive remote sensing, where a satellite is observing the reflected radiation from the sun and in various bands, and then use that information to detect various features like the forests or water, grass, bare soil, paved road, the built-up area, etc. will have different signals, so you can make out, and then you can create products which depicts various features of the areas that are being imaged, which can have various applications, including security applications. So as I said, the urban planning is one, as you may be aware, the smart city planning and all those are now making use of the satellite imagery to a great extent, so that the planning will be up to date and very efficient. And also for monitoring the construction, etc., it can be used. And many companies, including finance companies, use this technology, where the applications for getting the monitoring, and also for insurance, etc., where satellites can help in getting the actual damage, if at all, that has come in agriculture fields and things like that. Water resource management, India has, I think, every 15 days, the full pan-India mapping is done now. And this is a very important work done by remote sensing, because the country needs to know the status of water in dams, in various other water bodies, and how it will affect the not only the population that is living besides, but of course the irrigation system that is very essential for agriculture, forestry, and the area of forestry, the wastelands, and the health of the vegetation, etc. also can be monitored using this. And large forest fires also can be detected using remote sensing. So that is all being done currently. And agriculture very, very vast. And India, I think 13 types of crops can be identified using satellites, and its health and the acreage and the yield prediction, etc. are very important activities that are being carried out by Agriculture Ministry. Energy and infrastructure, rural development, maps and imagery, I don't have to tell you, you are already using this. And disaster management is very, very important application where, ISRO using its satellites is very active in providing kind of support. Today, we can predict the path of a cyclone to very, very accurate levels, and when it will hit, where it will hit, so that advanced action can be done to evacuate people and to reduce damage. And you might have noted that recently, in the past few years, the human loss that has occurred due to cyclones is very, very, very minimal because of the advanced system that we are using in disaster management. And ocean resource management is also done using, India uses the OceanSat satellite to get the information. And this, has the INCOIS, the organization which manages the ocean resources in India, has developed an application along with ISRO to predict, it is called PFZ, potential fishing zone. So using the technology to map plankton, which attracts fish. So the satellite gives information, the satellite-based application gives information to fishermen or the ground authorities, the area where the fisher folk has to go, where they can find fish. So this is a great application which has increased the yield like anything, which has reduced the fuel consumption, reduced the effort of the fishermen. And this is being used in Indian shores by the fishermen societies, and helping the fishing sector a great deal. As you know, India has a very large coastal area, about 7,000 kilometers of coastal area, where very large population of fisherfolk reside. And this sort of an application is very important. It has improved the livelihood of these fishermen. And we have, ResourceSat and RISAT. RISAT is a radar satellite. So these two satellites combinedly are helping the agricultural sector. And as I said, the various types of crops identification can be done using these satellites. And it is the pre-harvest production and forecast for each year is being accurately predicted using these kind of services. And surface water bodies, 15-day interval available at national level using ResourceSat. So the water body area, and using the in situ data also, it can be calculated how much water is available, and the situation as far as irrigation is concerned, and reservoir capacity estimation, etc. are accurately carried out using this. And then lastly, another important application is weather. This is an application that you are all aware of, you are all watching in TVs. So this particular picture shows the cyclone Amphan as it comes towards India, and the prediction helps India and India's neighbors also on the reducing the impact on the human loss of human lives, and planning the activities so that the damage due to the cyclone and other disasters can be minimized. So my intention was to give an introduction so that this can be carried forward. So thank you for your patience. I hope I have given you an introduction. So probably future, when we interact, we can get into details of each one of these in a great way. Thank you very much.
Thank you, Dr. S. Rakesh, for your very eye-opening presentation. And we'll be taking the questions after the second lecture is over. The few questions coming. And also, no, I'll be giving an open platform to all the students to ask the questions because they are the future for the country.
Okay.
And you'll be wondering, my 100 students are watching this presentation, at least 100 students, I see. Fine. So now I welcome Dr. Unnikrishnan Nair to give another overwhelming presentation on the human space, that mission for India. And certainly you'll be getting many questions by the audience. Dr. Unnikrishnan, welcome. Kindly share your slides. Yes. Could you kindly share the slide? Yes.
Yeah, just a minute.
Yes.
Can you see?
1
minute. Yes, now.
Yeah, now we can see the full. Can you come to the one and make a full screen of the slide? Could you kindly?
Yeah.
Yes, that's fine. Absolutely fine.
Thank you. Right. So maybe a few minutes I will talk on the India's future program or the current program, Gaganyaan, that is sending humans, Indians from Indian soil, and then orbiting the Earth and coming back. You know, the photograph what you saw on this slide is of that of Yuri Gagarin, the first astronaut. And this October 4th to 10 is a world over for the 95 countries. They're celebrating this as Space Week, World Space Week. As Mr. Rakesh was saying, October 4th is the date when Sputnik was launched in 1957. And the end date of the Space Week, October 10th, is the date on which in 1967, the Outer Space Treaty or the Magna Carta of Space was signed by many countries. Today is the last date of Space Week celebrations, and all ISRO centers they are celebrating by reaching out programs. They'll go to all schools and then give talks, and they will invite people, conduct so many programs. So this week is one occasion to reach out to all the people, those who are not directly dealing with space. Now in ISRO, the HSS, or Human Spaceflight Center, is the youngest center that was set up just 2 years back. And ISRO has many centers like the Space Application Center in Ahmedabad, or Vikram Sarabhai Space Center in Trivandrum, or URSC in Bangalore. And Human Spaceflight Center, the mandate is to take up human spaceflight program in a sustained fashion. And the first project under HSS is the Gaganyaan project with a very tight schedule. And on the right side is, you can see the artistic impression of this campus, which will be coming up somewhere in Bangalore, that is under final phase of approval. And as you all are aware, Dr. Sarabhai, the father of Indian space program, started the activities in 1960s. You know, this is one area where we have not missed the bus. The first decade itself, we also got into the program of space with starting as 1962 as Impospar, then later it has become ISRO. And then in 1972, Space Commission, or the Department of Space as it is today, has come up. And there are many programs also we have taken up during the course, like the INSAT program, remote sensing science program, which Rakesh has dwelt upon, so I am not getting into those things. We have a launch vehicles, like we started with SLV, ASLV. Those two vehicles are not in production now. Right now we have PSLV, GSLV, and GSLV Mark III. We had more than 70 launch vehicle missions. We have launched for more than 33 countries. 269 satellites were launched by these launch vehicles. And we have launched many satellites in many areas, as it was Rakesh was mentioning. And there were so many experimental missions, or we call as technology development missions, where we embark on developing new technology that will be used for future programs. For example, is a space capsule recovery experiment that has laid the foundation for the crew module atmospheric re-entry experiment or the manned space program. There are also technology demonstration on reusable launch vehicle. That is like an aircraft can we come and land. We had one experiment a few years back. And then using the air in the atmosphere and then use that instead of carrying the oxidizer, can we take up oxygen from the atmosphere and then use in propulsion? That is called a scramjet. That also we had a successful mission. We have two launch pads at Sriharikota. That is the spaceport of India. We know all satellite launching, the launch vehicle stations are on the eastern coast of eastern coast, because you know the Earth is rotating from west to east. So when it is living there, you get the benefit of that rotational speed also will be added to the satellites. So thereby there is a saving in fuel. And of course, there are other aspects like safety also. In case anything is wrong, we can definitely steer the vehicle to sea and then it can be destroyed. Right now, the GSLV Mark III is the most powerful, which can take 4 tons to 36,000 kilometers. And if we use that vehicle for a low Earth orbit, like up to 1,000 kilometers from Earth, we call it as low Earth orbit. And then it can launch about 10 tons. So these are the major launch vehicles that ISRO right now producing: PSLV, GSLV, and GSLV Mark III. So as I was telling, this 2007, this was a very unique mission. You know, satellite launch vehicles can take a satellite by incrementally adding velocity, and it takes to the orbit. And when it reaches an orbit, say like the 800 kilometers, the satellite has acquired a velocity of around 8,000 meters per second. You can just imagine 8 kilometers per second. In a second, it will travel 8 kilometers. That is a type of energy that is imparted to that satellite by the launch vehicle. And we need, for a given orbit, if you want to stay there, you need a minimum velocity to balance the centripetal force or the acceleration due to gravity. But then once it is launched, how do you systematically kill the energy and then bring it back to a destination on Earth? Because this is the basic technology that we need if you are thinking about manned space flight or bringing back anything from space, say resources or other resources from asteroid or anything. This SRE was launched in PSLV along with the Cartosat in a dual satellite configuration. You can see on the right side, the capsule has got a black tiles, which is like the space shuttle tiles. That is the thermal protection system. You know, when it re-enters, because of the re-entry heating or because of the friction of the capsule, because it is traveling at 8,000 meters per second, when such a high velocity satellite is re-entering into the atmosphere, a lot of heat is generated because of the friction. So the idea is to shape the vehicle in such a way that the less heat is transferred to the body, and the thermal protection system takes care of the thermal management. So in this case, the outer temperature could be as high as 2000 degrees centigrade, whereas the inside temperature is close to 40 to 50 degrees centigrade. This is a type of thermal gradient. What you see on this slide is the capsule floating in sea, and it is being required by the Indian Coast Guard. And this has laid the foundation for many future missions like reusable launch vehicle or manned missions. And we did some microgravity experiments because, you know, when you go to space, there are many features that we can use for microgravity experiment. First is the deep vacuum. Second is the microgravity. We get a very low level of microgravity. And this is an ideal place for doing many microgravity experiments. And then before the manned mission in 2014, we had the first full-scale crew module, or the capsule where the crew is living, that was hurled into space by the GSLV Mark III in its maiden launch, and just gone to 125 kilometer and acquired about 5.5 kilometer per second. And the capsule was controlled by the thrusters on board, and then precisely made to land at 1,600 kilometers away from Shar in Bay of Bengal. And towards the end, about 14 kilometers downwards, we started deploying parachutes, multi-stage parachute. And this parachute has reduced the velocity. You can just imagine we started with 8,000 meters per second in orbit, or in this case, 5,500 kilometers per second. And that splashed down. The velocity was brought down to 8 meters per second, which is quite comfortable for humans, human physiological limit. And what you see on the right side is the capsule is getting encased or encapsulated into the payload fairing. And the middle one is the launch. And this is a snap taken by the overflying aircraft. You can see when a capsule of this size is landing or splashing down into the vastness of sea, we need to locate it. So we employ different methods. What you see is that green patch is a dye which is spread all around the capsule, and this can be seen from a height by the overflying helicopter. And there are beacons that will send out signal. There are so many multiple redundant ways of locating the capsule and then recovering. Subsequently, in 2008, when you have a manned mission, the man is sitting at the top of a huge rocket where the 98% of the mass, say for Roskilde Mark III has got 700 tons of mass, and the huge explosion or the propellant, he's sitting at the top of tons of propellant. So the in manned mission, the idea is at any cost, we should see that the crew is bailed out, they are rescued. We are not worried about the success of mission, but at any stage, there should be a provision to bail out the crew. So we also needed the escape system. That is what this slide demonstrates. What we do is, suppose something goes wrong with the vehicle, there are some high quick acting solid motors at the tip of the vehicle that will be fired, and the capsule will be separated from the vehicle, capsule with the crew, and they will be taken, say, 2 to 3 kilometers away from the vehicle. And then as you see in the second snap, the capsule will be released, parachute will be deployed, and then they splash down. So we are not worried about the vehicle will be destroyed, but the crew will be bailed out. So this is a very critical technology. This we demonstrated in 2018 before the Gaganyaan program started. Now, if you look back, these 50s and 60s, the era of Cold War between the then United USSR and the USA, and they were all fighting each other or competing with each other to achieve the first in space. In fact, this 50s, 60s, 70s, we can probably call it as the golden era of spaceflight, thanks to this Cold War. And obviously, Russia was making, or Soviet Union was making many first. So the first dog, Laika, was sent into space, and of course, Laika lost its life. Laika was just picked from a Moscow street, and it was trained and it was sent. Of course, they were knowing that they were not having the technology to bring it back. At that time, same time, USA also was working on sending life, seeing the feasibility of life in space, because at that time nobody was knowing what will happen if somebody is going to space. Can life sustain, or even what is the type of radiation, what type of difficulties life will be experiencing in space. And this monkey was called Gordo, and that also had a problem with the parachute, and it has lost its life. And then in 1961 and 2021, this is Diamond Jubilee year of first flight. It was 12th April 1961, Yuri Gagarin made the historic flight. And shortly after that, Alan Shepard, 5th May, he made the suborbital flight. He has not gone to space, but he made a suborbital flight. But John Glenn was the first American in 1962. He made the orbital flight. Unfortunately, Yuri Gagarin, we lost this precious life during a training in 1968. He was in fact getting ready for his next mission. And you can see on the right side, the Vostok 1, that was the capsule in which he has gone. Just a small capsule, there's only hardly 1.5 meter diameter. It's a cramped space. Usually such vehicles, which is coming back or re-entry vehicles, they'll be optimized to, so size will be minimized, mass will be minimized, because we don't have to carry so much of weight in terms of parachute and other thermal protection systems. So the optimization is to minimize the mass and volume of the re-entry capsule so that the other subsystems can be lightweight. Now, but if you look, more than 542 people have gone to space. Now, when we started the Gaganyaan program, many people are asking, are you sending some animals like fungi or something like that? But there is no need for sending such things now. First of all, we know that more than 540 people have gone and come back. And at any time in ISS, there will be some 5 or 6 people always orbiting there. And now the measurement has improved so much that any parameter you can measure so accurately, and then you get idea about it. And you can see some 20 countries, including India. The first astronaut of India, Rakesh Sharma, who went to space in 1983. And now the fourth one, that is, we are all looking forward to. Who will be that person? So when we make satellite launch vehicle, there is no issue because it is an inanimate object. If anything goes wrong, we can destroy it. The moment you add a humans into the system, there are so many other aspects we need to take care of. One is the man-machine interface. See, humans are prone to make mistakes or errors. So your system should be error-proof. And then the physiological aspects, because satellite is not bothered about microgravity or the acceleration to some extent, but humans, they all develop different symptoms when they are subjected to acceleration or microgravity or vibration. So there will be restrictions in terms of physiological aspects, psychological aspects, because he is going away from Earth and it is an inherently adventurous thing. It is not that it is like an aircraft, it is so safe, but there could be issues. And he is leaving his dear and near ones on Earth and living away and going away and away from Earth. So a type of psychological issues, and he is in a very cramped space with limited resources. So everybody probably cannot become astronaut. So you need such minimum mental strength. That is why usually all over the world, Air Force test pilots are the first choice. And for us also, it's not an exception. We are also, the first mission will be by Air Force pilots. Gradually, definitely the civilians also will find space. Then we need resources because we are carrying all the resources, food, water, and all the medical care. You cannot take a doctor to space. So the crew will be trained to take care of the medical emergency and all those all sorts of things. So the introduction of human into the system is creating a lot of other technical as well as other issues which we need to resolve. Now, when you go to space, there are so many things waiting there. One is the microgravity aspect, how humans are reacting to microgravity. Second is the space radiation, which can vary depending upon solar activities and the orbital conditions. And the space has temperature extremes from -100 or 120 to plus 150 and so on, depending upon the sun position. And then you will not get fresh food as you get on Earth. The issues of isolation, so many things. So we have to address one by one when we take up the human spaceflight. So this just demonstrates the weightlessness, the concept of weight. You know, weight is the reaction on your body. So when you are standing on a platform, the platform is exerting a reaction on your body. That is called weight. And if you remove that platform, there is no reaction on your body, and then just you fall under gravity. So right side, that is commonly called as Newton's cannon. You can see if you jump, if a person it's only a theoretical concept. If you jump with some velocity, yeah, you will fall down like this. If your horizontal velocity is more, you will fall at a farther point. And if you can increase the velocity as such a way that you can always be in orbit. So the point is that the moment he is falling, jumping like this, he is under a free fall condition or a weightlessness condition because there is no platform or something supporting structure to react. So precisely we do the same thing by sending a satellite. Of course, the velocity addition is in stages by the rocket launch vehicle, and each stage will add some velocity and finally you circularize and stay in orbit. So when absence of or the zero weight condition, but then we need to train the crew how you can give such a weightlessness in space. So the simplest thing which can give maximum weightlessness in space is like 25 to 30 seconds is a parabolic flight. These are all special aircraft where the interior seats and other things are removed, and then you pad up with soft foams, and then you pull up a parabola, and then you just free fall the time. Like you pull up with an acceleration, and here just the acceleration will be, or the vehicle will be in a free flight condition. It will just go up and then come back, and then again you start, and you make so many loops. You get 25 to 30 seconds. During this time, the astronaut candidates, they will be asked to do many experiments like eating food or getting into flight suit and other all sorts of things. Now, when a human body in a weightlessness condition, many things happen to the body. You can see on the left side top, a simple candle flame. In Earth environment, it will be like this because there is convection, and because the convective current is going to be different in space as well as in 1G condition. So if it is in space, it takes a totally different shape. The convection process is different. Like that, you know, we are all acted upon by gravity, and about 60 to 70, you know, 50 to 60% of the body is fluid, and the fluid is acted upon by gravity. But in the gravity or the weightlessness condition, the first reaction is the fluid will shift to the top of the body. So then when the body fluid is shifting up, then your internal organs will get a wrong signal that as if you have consumed more water, and then kidney will start pumping out more water. So the urination or the feeling of urination is the first symptom that we get when you go to space or when you experience the microgravity. Second is the type of, you know, once the fluid is shifting up, your face itself will change because of it. There will be a puffy feeling because of the fluid accumulation. And there could be the sensors also will get wrong signals because all the sensors are conditioned for the 1G condition. Then there will be conflict of sensor inputs, which can lead to space motion sickness. And you know, the entire your skeleton system is acted upon by 1G. When that 1G is removed, you will naturally grow by an inch or so because of the absence of gravity. And then so many things happen to the body. You can see if you are in space for a long time, because of the fluid shift, you get something called a bird leg syndrome. Your legs will become thinner, whereas your upper body will become thicker because of the fluid collection. And the face, the same person will look different. There will be changes because of this fluid shift. And the astronauts, as I was telling, they grow taller in space because of this process. So many things happen to the body, and how you acclimatize and how one comes out of this is, I know that is a part of the training and then selection of the astronaut for the mission. And there could be so many other issues. You know, in ground we have abundant oxygen. We are not aware of inhaling and exhaling, but in a capsule, a very small capsule, we adjust the parameters like the oxygen level, carbon dioxide level, and the total pressure, partial pressure, everything. We try to mimic the Earth atmosphere. So if the carbon dioxide is too high or oxygen level is too low, then the astronaut breathing rate is increased. So he gets into a situation called hyperventilation, which can create many issues like dizziness, blurring of vision, and sorts of things. Doctors, you know better it. And when he is in space for a long duration, as I was telling, there is a fluid shift. And then unless there are some separate system to see that the fluid is trapped in the lower body, he may face problem while coming back. So this aspect, how you are avoiding such stress by creating a suction on the lower body or by taking special fluids to create that situation, that becomes another part of. Then motion sickness, because of the sensory conflicts, there will be, it depends upon, it's a subjective situation. Many people will face different things, but 90% or more than 90% of the astronauts, they face this space motion sickness, but how fast they recover, that is a measure of their agility and their quality to become an astronaut. But there are drugs for it, and there are training programs for it. And similarly, when the oxygen is less than it needs, then you get numbness in fingers, lack of coordination, that is called hypoxia. Another issue is where you have a capsule where it is pressurized to the 1 atmosphere, and due to say some meteoroid or some debris hitting, if there is a sudden depressurization, then your body is subjected to a vacuum suddenly the outside, and then it can create a lot of problems, like the gas that is dissolved in your fluid that will suddenly expand, and then you have joints, pain in joints, and all sorts of things, itching, vomiting, and all sorts of things. So this is a sudden decompression of the cabin due to some reasons. You know that when suppose somebody is suddenly they are experiencing this vacuum, your body will expand twice the volume because of the internal pressure, and the water in tissues, they rapidly turn into water vapor because of the lower vapor pressure, and the gas in your tummy will expand and pushing the diaphragm up. And then there are so many things which can happen if medical care is not given within say seconds. Definitely it can lead to a very catastrophic situation. And then what is shown below, a technician was accidentally, he was subjected to a very low pressure during one of the flight suit testing, and then he was subjected to 22.5 kilometer altitude pressure for over 1 minute. That is the only data available where a person was subjected to more than 1 minute, but he had a lot of problems, but he survived. And then on the right side, you can see a decompression chamber. This chamber, here we can simulate the decompression rate, and then the crew with flight suit, they will be subjected to this decompression condition, and then we test the effectiveness of the flight suit to see that the crew is safe even if such things happen. In fact, this has happened in one of the Soyuz flight. The flight was Soyuz 11. The mission was completed and they were all returning. But when they landed, precisely the Soyuz capsule is a land landing capsule. When they opened the hatch, they found that all the 3 cosmonauts were found dead. The reason is there was a pressure equalization valve. You have the capsule with an internal pressure. At some 5 or 6 kilometer altitude, they open a valve and the internal and external pressure will be equalized. But inadvertently, this valve was operated in space itself when they started the descent program. And the entire cabin pressure was lost. And then finally, the situation was very catastrophic. And after this, it has become mandatory that the crew should wear flight suit during ascent and descent phase, which are the dynamic phases. If they had worn the flight suit is a artificial garment. If there is a depressurization, immediately pure oxygen will be injected into the space between the body and the flight suit, and it will be pressurized, and they can stay there for 1.5 hours safely. But now, yes, all the astronauts are wearing flight suit, and this was one. And so there are so many accidents. In fact, many accidents where people have lost their lives. So here the significance of this flight suit or intravehicular flight suit, which is like the crew module cabin, where there will be valves to inject air or oxygen, and then there will be the astronaut can adjust the volume or the pressure inside, and there is a sealed helmet where they can see it. So once they are into it, their mobility is restricted because it's not a very comfortable situation. But the situation is essential to save their life, and then they can come back within 1.5 hours. Now the Gaganyaan is India's manned space program. You know, on the left side, what you see is the GSLV Mark III, conventional satellite launch vehicle. So we are using the same vehicle and then convert it into the Gaganyaan human-rated launch vehicle by just replacing this portion with this system. This system is called the crew escape system, which I have initially explained. And within this, we have the orbital module, which has two parts, as I will be showing later. And it has got two solid strap-on motors, and there is a liquid thruster, and there is a cryo stage. So it's just 3 stage. Once the cryo stage has done its job, we are in space. Now, this is that orbital module. We call it as the Gaganyaan module or orbital module. It has two parts. One is that crew module, which this brown one, which is the one where the crew will be residing and they come back. This is a pressurized one with all facilities. And there is a service module, which will have its function during the orbital phase. And once it is deorbited, this will be separated, and only this capsule alone, this crew module alone, will be coming back. So this crew module can take 3 crew. They can go to 400-kilometer circular orbit, and then they can come and splash down in either Arabian Sea or Bay of Bengal. Usually we prefer Arabian Sea because that is calmer compared to the Bay of Bengal. And the vision for the human spaceflight program, for the Indian human spaceflight program, is we will have a sustained and affordable human and robotic program, because we know that these two are complementary in nature.
I think
Power failure, I think. In
power failure.
Bangalore is famous for that. So
Okay.
kindly bear with us.
Just a moment.
Yeah.
I think in the meantime we can discuss.
Yeah.
We can discuss. Let him join. Okay. I'm getting. Yes. So I think let me get one question today got for Mr. Rakesh.
Yeah.
So that is actually the question is that first one, that will there be traffic jam for physical space or bandwidth jam after successful completion of LEO project?
Okay, this is a much debated topic, and the problem is that we are not used to these thousands of satellites orbiting the Earth, and the control of the orbits and the knowledge of each satellite's course beforehand, and also the courses of various space debris that is orbiting there is important. So what I'm saying is the space situational awareness has to be at a very high level to take care of the satellites and the collisions and the problems that it can create.
Yeah.
So I think this is an evolving technology, and space debris, of course, is a problem that has been discussed for so long. And yeah, so now there is a good system available as far as space situational awareness, and up to 10 centimeter object can be tracked. And now all these satellites, recently a collision was about to occur between the Starlink satellite and another satellite, and it was detected and avoided. So probably like in the ground, when the traffic becomes large, a possibility of a collision is larger in space also. But this is the way it is going to be, and we have to have we have to understand that this is a reality and put in system so that it does not get into a very catastrophic mode.
Okay. I saw one more question. The question is thank you for your presentation, Dr. S. Rakesh. Then, sir, what do you think? What will be the future of surveillance, not only for the security but also for the common man? That was that. Our surveillance has some question.
Yeah. surveillance has always been a topic which has been very dear to the satellite technologists and from the security domain. Of course, surveillance is done not only with satellites; it is done with the aircrafts now, more with the drones. So, drone plays a very large part as far as surveillance is concerned. And from the civilian scenario, this technology is used more for remote sensing and related applications. And I don't know whether you can call it surveillance, but if surveillance is required, the same technology has to be extended to a particular area, depending on the security situation. That is why it is always deployed in areas where you face some security-related issues. So we need continuous information coming out of there to make some assessment about actions to be taken in that particular area. So these technologies are already there and it is evolving also. So drone is increasingly coming into prominence, and probably in future you will see more drones being used in even civilian areas also. Now I think Unnikrishnan has come back.
Yeah, he's come back.
Work. So we will go back to his presentation.
Sorry, yes, there was a sudden power failure, which is very rare here. Okay, I think you can see the slide, I hope.
Yeah.
Right. So we need, we are talking about two systems. Earlier, we have been very familiar with the engineering system where you have a human-rated launch vehicle, orbital module, mission management, all those things deal with the engineering aspect of it. Of course, there are new technologies that we need to develop, like, say, for example, green propulsion. Conventional propulsion use very toxic propellant and oxidizer, whereas for a manned mission, we are going for a hydrogen peroxide-based system, even if there is any propellant leak or anything, but the crew there is no safety threat to the crew. Then on the other side, we need so many other aspects like crew selection and training, life support system for the survival of the life, flight suit, in-flight nutrition and health, waste management in space, and the onboard medicals and survival kits, and a lot of standard operating procedures for a nominal as well as off-nominal mission, what the crew should do, what the ground staff should do, how to bail out of situations, because nominal is always nominal, but there will be umpteen off-nominal situations. So the crew will be trained to take care of such situations. Yeah, this is a cutaway view of the orbital module. If you just make a plain vertical cut through the orbital module, you can see the systems there, how it is populated inside, and then which are the items, like, we have a pressurized double-walled crew module. So the structure itself is double-walled. It has got two walls. Even if the external one is pierced by a debris, the inner one will take care of that. And the external wall has got a thermal protection system. It's a very robust thermal protection system which will take care of the re-entry heating. And all life support system like food, water, oxygen, gas bottles, etc., are all placed either in service module or orbital module, depending upon the phase of the mission. And the entire system will be in a controlled, because the crew doesn't have much role, unlike in an aircraft. Here it is a fully autonomous system, which has got a closed loop navigation, guidance, and control system, which will take care of the end-to-end mission. But there are certain crew intervention provisions are given in case anything goes wrong with the system. And unlike in a launch vehicle or a satellite, here the level of redundancy is high. We go for avionics systems will be in quadruple mode. 4 systems will be there. In case one system fails, it will switch over to the next system. And the parachute system will be there. 2 systems will be there. In case one fails, the other one will be activated. Like that, the reliability as well as the structural margins and the pyros required to activate the systems, they are all one level of more redundancy we have implemented to take care of, to make the system more reliable and to avoid any catastrophe during the flight. So if you just look at the mission, this is the ascent phase. The Mark III is going up. Initially, the 2 solid motors will be firing. Once the propellant is consumed, both the solid motor cases will be jettisoned. It will just fall back into sea. After that, this is the crew escape system, which is which will be used during the atmospheric phase of flight, that gets jettisoned. Then the second stage is ignited. Then the cryo stage is ignited. Once the cryo stage has completed its propulsion, we are in space. Then the solar panels are deployed, and then the crew will be in space for nearly 1 week. Once that phase is over, the orbital module will be reoriented by the propulsion system, and then it is deorbited, because when you are in orbit, your velocity is tangential to the orbit. So if you can tilt the velocity vector by a small angle by firing thruster in some other direction, like your parallelogram law if you fire give a delta V in some other direction, the velocity vector can be tilted towards the ground. Then it just starts falling under gravity. Once that is done, the service module has done its job. So we separate it out. It just comes back, and then it gets, it re-enters, and it cannot survive the re-entry heating, and it will be lost. Whereas the crew module will be having its set control. It re-enters. Then through aero braking, that is using the aero braking itself, more than 99% of the energy will be killed. And only the less than 1% only will be managed by the 3-stage parachute system, which will be deployed. And then it is splashing down somewhere 200 kilometers away from the Indian coast. And then our Indian Navy and other related agencies will recover them from there. Now, this is the escape system which I was explaining, just to show the various engineering aspects. If anything goes wrong, you activate the system and it goes up, and the capsule comes out, parachute is deployed, and then the crew can be easily rescued. These photographs anyway I have shown earlier. This is how it was tested. So the advantage of an escape system is that just puts fewer moving parts and it is less complex, so that we can always make it an order of magnitude higher reliability, with the higher reliability than a launch vehicle. So always our thrust is to rescue the crew. So that is how this principle behind the escape system. Now the point is, what is the orientation? What happens to the human body when the G is acting on a body? So this particular slide shows different positions of human body and then their tolerance to acceleration. You can see this poster, that is this supine position where the crew will be facing up. This can take maximum G condition, and then you can see that all the human space vehicles, they orient the crew seat in such a way that they are just oriented normal to their chest during ascent and descent, so that they can take better abuse of this gravity condition. And then, of course, when the G is more, many things will happen. Like if it is 2G, your weight is doubled your normal weight on ground. And if it is 3G, you cannot stand. You cannot stand on your own. That is why you will be always on a cradle, and then you will be supported. And during the ascent phase of the launch vehicle, the G level can go up to 4G. So humans can definitely withstand 4G in that particular position. And under extreme conditions, suppose the abort condition, etc., the G could be as high as 12G, but it is for a very short duration of 1.5 or 2 seconds. That also crew can withstand. So the crew, when he goes up, he is subjected to acceleration. And then whenever there is a staging or the stage separates, momentarily is exposed to weightlessness. Then he reaches the space where he is in a weightlessness condition. Then he comes back, he is again subjected to acceleration. So its body is subjected to different types of acceleration. And when they come back after spending a few months in space, their body has become weak because of many reasons of being in space. Then the re-entry becomes more problem, or it has to be addressed in detail. And then the rehabilitation becomes a little more involved. So there are many events that happens where the acceleration or deceleration crew is subjected to these conditions. You can see during the ascent phase or during the parachute phase, when the parachute is extracted, there will be acceleration in different conditions. And when it is going and impacting onto the water wave, depending upon the water wave or the position of the water wave and the angle at which it impacts, there will be deceleration onto the crew. So the design of the crew seat with its attenuation system is also very important to see that the crew is not given very high acceleration, or the crew injury criteria is not violated. So we need a crew, we have a crew seat inside with a special absorption system, with an energy absorption system in any direction, whatever be the direction it falls, to will ensure that the crew is not subjected to the beyond the threshold of his endurance. Like this crew seat attenuation itself is a very interesting thing. There are designs based on biologically inspired design. Like, when a cat is just jumping, you would have noticed it's not all the four legs are not simultaneously touching. It will land in such a way that the first two legs will take some load, and then immediately the hind legs will be taking the load. So the peak, the big peak is split into two small peaks. So this similar concept is being used in crew seat also, where through a suitable mechanism, you ensure that there is a time delay in between the forend and afterend points where the loads are acting. In fact, such systems are, when we land on our food, it has got its own attenuation system internally. It's like a leaf spring. It softens our landing by the special design of our feet itself. So certain systems like energy absorption system, which are naturally in our body, we make better system which can take care of more impact loads, and then such systems will be implemented as part of the energy absorption. This is how the crew seat and its attenuation systems are connected to the point. And you can see the bucket where the crew is sitting. It is profile, or the shape is just like the human body. And you can see how the bucket is made. See, the astronaut will be wearing a special dress, and there is a plaster of Paris, a sort of a fluid, semi-fluid situation where a fluid, where the body will be just, the shape of the body will be produced or molded into that, and that mold will be used to make the liner. Thereby, we ensure that the back of the crew is perfectly butting on the seat. Thereby, maximum area is available for load transfer. Like a child in a cradle, where the cloth of the cradle is protecting all around the body, so that child feels comfort. So, what is comfort? When you sit on a cushion, the cushion will take the shape of your body, and your weight is distributed over large area. So the reaction on your body is less, so you feel comfortable. So the same philosophy for a crew seat, where when the crew is subjected to higher acceleration, if you can distribute the weight over larger area, then the endurance limit can be increased. Similarly, the vibration, the human body has very low frequency vibration, less than 0.1, less than, for 10 hertz and below. There are so many systems. A body can be considered as a combination of hundreds of spring mass system with a low frequency. So so this becomes an important criterion when we design the vibration levels. So when we see that the vibration levels are not exciting any of the human sensitive frequency, which can put them into sort of space motion sickness. Then the next part is the radiation. There are different levels of radiation, different sources. First part is the galactic cosmic radiation. Then the radiation from solar cosmic radiation, from Van Allen belts. There are other phenomena called South Atlantic anomaly in Leo, where the Van Allen belt comes in contact with the atmosphere, and then locally the radiation level can change. All these things can add to the radiation level. So for an astronaut, the carrier dose or the radiation dose becomes one criterion for his how many days or months he is going to be in space. So usually in a shuttle 8-day mission, they will be subjected to 5.59 millisievert, that is the unit for the radiation. Whereas the NASA has specified a carrier average for the typical astronaut is 6,000. If it is crossing 6,000, then naturally they are not considered for further missions. So this is another important area for us. For a short duration mission, radiation is not a problem, but still we have an active dosimeter. We are going to measure what is the type of radiation. and there will be passive dosimeter also, and then ensure that radiation levels are less. One more point, for our mission, the astronauts are going to be inside the crew module. They are not coming out, they are not doing any extravehicular activity. That condition, the radiation becomes more problem. And the radiation is still worse when you talk about mission to Moon or Mars, or when we cross the Van Allen belt and moving to other planets. But this also is the one important area we need to address. Then the environmental control system, this is the how do we mimic this photosynthesis and all other things inside a small capsule. You can see that a typical astronaut, he consumes about 0.9 kg of oxygen, about 1 kg of food and water, and all these things will come out as waste. So we need a system where food, water, all these things are there, and the waste management is done, oxygen, carbon dioxide, and the small cabin odor removal, as well as how you maintain the carbon dioxide level within limit. All these things become part of a system or a system of systems called environmental control and life support system. Here, it has got many subsystems. The net. Can you hear me? Hello?
We can hear you, yes.
Yeah, momentarily again power has gone, so I just checking it. So there are many subsystems. The natural process, we are converting it into small subsystems like cabin pressure control, thermal and humidity control, air revitalizations, like so many subsystems, and all the subsystem will be realized and integrated as shown here. What we do, see, the heat can be collected from the cabin air. That will be passed through a heat exchanger where the heat will be transferred to a fluid. From that fluid, the fluid will take the heat to the service module where we have radiators. That radiators will reject the heat into space. Similarly, we have special canisters which is made out of lithium hydroxide plus activated charcoal, and the cabin air will pass through that. Lithium hydroxide will absorb the carbon dioxide, and the activated charcoal will remove the odor within the cabin. And such canister has a life of about 1 day. Once 1 day is over, the astronaut will physically change the canister with a new one. Like that, the canister will take care of the air revitalization part. So all these systems we need, and these systems are now under development and testing. And then this will be integrated, and the entire system will be tested and demonstrated. And the extreme cases like low pressure, maximum increase in temperature, or high heat input, or low different levels of partial pressures of oxygen, all these conditions will be tested. And there is a controller which will take care of automatically all these parameters based on the feedback from sensors. Even the crew health parameters are also being monitored, like the partial pressure as well as the ECG. These are all parameters that will give an indication about the health of the crew. Sometimes health of the crew also can become a condition for abort. During the ascent phase, the crew is feeling unable to fly because of some complication developed out of medical problem that can lead to a abort of the mission. There is a other issue which was not there in 1960s is the space debris, because human beings have added so many debris, man-made debris into space. You see the space looks like something like this. This debris, because of the satellites, or the satellites may get exploded, or because of the anti-satellite experiments what they do in space. And now many countries are becoming spacefaring, and their satellites are there. And many countries, they don't just leave the satellite there after its life is over. So it becomes an issue. And then any debris, if it is coming and hitting the capsule, and the debris are flying at 8 to 15 kilometers per second, so they can easily pass through the structure. So we are taking care of this debris protection by going for a sort of a bumble Whipple shield concept. That is, we have a standoff. When the debris is hitting, the first hit, the debris is converted into a set of cloud of debris with small particles. And this cloud with small particles, maybe millions of small particles, that cannot pass through the second layer. So this is one concept. Similarly, different concepts are used for taking care of the debris. And you know that the more than 10 centimeter size debris are being tracked worldwide, and we have the data. If you know that more than 10 centimeter debris are approaching us, we can use our thrusters and then maneuver. But the design is done for less than 10 centimeter, where the debris are not properly documented because of the size and the limitation in tracking such small components. Now, you know, our astronaut trainees, they have been picked up from Indian Air Force, and we had a very detailed selection process where we started with 60 candidates, and then there was a screening committee, and there was a medical evaluation. We had help from the Russian medical team also, and then through a series of process, finally we had 4 candidates, and these 4 candidates, after the selection process, they were sent to Russia for a basic training course, and that training was for nearly 1.5 years. They had come back 1 month back, and now we are going to have this Gergenian specific training in Bangalore. The training facility is nearing completion. You can see a typical training program will be like this. This 3-semester program. The first semester, mostly the theoretical basics will be given importance, and then gradually flight system, mission, space medicine. It is like a 3-semester course with the credits and other things. So the experts from academia, ISRO, industry, they all will be taking part in imparting the training to the crew. This is the training they have undergone there at GCTC, that is Gagarin Cosmonauts Training Center in Russia. They have been subjected to Soyuz. They have used the Soyuz system. They had a survival training in snow. That is in case if during an orbital abort, if you land in sea, or if you land in forest, or if you land in snow, they will be trained to survive. For example, you have the parachute system. The parachute canopy can be used to make a tent. And they have a survival kit inside where they have a rifle, pistol, they have knife, they have the match stick, and all sorts of things to survive, and then food. They can survive for 2 days. They can make short shelters and stay there. So this is part of the survival training in case of any abort. And there are all these things they have undergone, and the Russian and the Indian leg of training we are going to come in soon. So this is what I was telling about the microgravity, simulation. This also our astronauts, they have undergone very extensively, and they have been trained to don and doff the flight suit, how to take food and other things. We have so many milestones coming up. We will have, let's see, on the left side, what we have shown is the capsule will be taken to 5 kilometers with the help of Indian Air Force, and they will drop it, and the parachute system will be tested and tested and tested. Some 17 tests are planned. Second is the escape system. We have a small vehicle. The design is only realized. On top of it, the vehicle, the crew escape system will be kept, and this vehicle will take it to a dynamic flight condition. From there, the escape system will be validated. And then we will have 2 identical unmanned flight, and that will be heavily instrumented before taking up the manned flight. And we have many experiments. In fact, we had a call for opportunity. We have given the proposals. We opened the proposals to many academia, as well as a national level advertisement was given. We got some 28 proposals. And as shown here, some experiments are shortlisted. They will be flying in the unmanned flight, like IICT Secunderabad, IIT Patna, TFR. And I have this medical, those who are participating in this seminar, I urge you to come out with very exciting cutting-edge experiments in related to medical field. We can definitely fly in, if not in the first or subsequent missions. We also have a humanoid, as I was telling, human robotics is also part of it. It's a half humanoid which can mimic certain activities, which can do certain functions. Definitely such robots can be used later for satellite service or debris clearance, or maybe if you are looking at space mining where there's hazardous environment, probably humans cannot do it. So it's a complementary role, humanoid or robotics we have, and that area also we have initiated. And this humanoid will be flying in the first unmanned flight schedule for next year. And if you just plot the ground track of the ascent phase, this is how it is looking like. And this is the area where we will have the recovery logistics in case if there is an abort during any phase. Nearby the ship will approach and the crew will be rescued. So the entire recovery process is led by the Indian Navy, and all other agencies like the Coast Guard and other NIOT, they are all giving their resources like ships and other things. They are participating in this major program. We will have so many places this recovery logistics lined up to rescue the crew in case of any abort also. So the primary landing could be somewhere near Port Blair after the 16th orbit. And it is also possible we can land in case suddenly there is a depression is developed, then you can go and come back and land at this place, which is in the 17th orbit. That is the earliest opportunity. Obviously, we can stay there for 5 days, 6 days, because we have the resources for that. Once they splash down, you can see here there is a typical a ship with a opening at the rear where the capsule can be just dragged in and the crew can come out. So this is how the primary recovery operation which we are planning right now. This slide shows the recovery we have done in 2014 when the Care capsule was splashing down 1,600 kilometers away from Shah. You can see the Coast Guard was involved in this task, and the capsule was loaded onto the ship and then brought to the Ennore space Ennore port, and from there it was taken to Sriharikota. So what you see here, this brown is the thermal protection system. This area, this was the area where the parachute and the system were stored. Once the parachute is deployed, that cover or there is an apex cover that gets jettisoned at 5 kilometers and the parachute will be released. Once splashed down, all the parachute will be released because we don't want the capsule to be dragged away like a sail. So all the parachute will be released with the pyro releasers, and the capsule will float and the rescue team will go and then rescue. And the capsule also is designed in such a way that it is like a Tanjavur doll. It is hydrodynamically monostable. That is, whatever fashion it falls into water, it is always upright like this, so that the safety of the crew is ensured by design of the configuration itself. So Gaganyaan is a national program. It is not that ISRO centers. How many national labs, DRDO labs, academia, and ISRO centers, industries. It's really a national. It's not only a national program. In fact, international agencies are also involved in this. You can see so many dots are there. All pan-India program with the participation of many national agencies, and definitely this is going to open up many areas in advanced technology, microgravity experiments. It is going to open up a new area called bioastronautics, where the survival of human beings in low gravity, and then how they are equipped to step out of Earth's atmosphere and go to Moon and Mars. So all this will be dealt by the bioastronautics, the new realms in materials and manufacturing, new process. So it's it's going to excite the entire science and engineering and medical and other community. There will be so many opportunities, so many spin-offs. So I have just shown 4 areas. Definitely, there will be many areas like this we can identify. Now, you all know that the space tourism is now it's a very hot topic. Seats are being offered at so much of price. There are many parties. Recently, Blue Origin, Virgin Galactic. It's space tourism. The flight is not like they are not going to orbit. Just like a parabolic flight, like throwing a stone up. They just go up, just cross the 100-kilometer limit, which is called the space limit, and then just come back. So there is some 6 to 7 minutes of weightlessness they experience, and it is an adventurous mission. You can see a glimpse of the Earth, and then they come back. But it is going to be a major. The space tourism is viewed as a major activity by many countries. In fact, in India, we are not yet started, but it is expensive. But I hope with the recent reforms and with more industries into this area, this also will be taken up, and then this will be giving its due importance in years to come. So many things are happening across the world. Many private parties are having manned space flight. You know, the Elon Musk SpaceX, they are now sending humans to space station and back. He has got a more ambitious plan. Many private parties are developing manned spacecraft. And there are many even more ambitious program like the Artemis program where NASA is working on, where they are trying to have a space station around moon and then they go and land in moon. So that moon is taken as an intermediate post from where they can go to Mars. Mars is an area where scientists feel that though the atmosphere is 1/100th of the atmosphere of Earth, a habitation system can evolve probably in future with the technology advancement. And what you see below is the SpaceX Starship vehicles. He is designing a huge vehicle which can take hundreds of people to Mars. And then the same vehicle SpaceX is planning to use for intercontinental transportation, say from US to Australia within say 1 hour. So the prospects of human spaceflight all over the world, it is picking up thanks to the contribution or the involvement of commercial agencies. And we also have in India also the situation is emerging. Many new startups as well as commercial firms are showing interest in space program. I would like to conclude my talk with the following points. Yes, we have a Gaganyaan program, which is going to be the first in a series of human spaceflight program. And if you look at worldwide, there is a renewed interest in manned space program. Many commercial firms are investing in this program. The humanity is looking for resource utilization in asteroids, moon, and Mars because of many reasons, like Earth resources are depleting, fuel is depleting, population is increasing. It becomes a necessity for human to find out other habitat, migrate, and populate to other place. And it is not far away that colonization of moon and Mars, it is no longer a science fiction. And this is not going to be a single state business. It will be a huge collaboration opportunities are waiting there for everyone. And thank you for this opportunity. I have given my mail ID here. If you have any specific queries, you can ask. But that U is small letter, it is not capital. Thank you very much. Any questions?
Yeah, so excellent presentation, very thought-provoking. So first I'll take some questions from the chat box, then I'll have few more questions to both of you. Dr. Rakesh, there's a question for you. The SpaceX has completely redesigned and the space suites, unlike age-old NASA design. How is your space suite designed?
I think Unnikrishnan is the right person to answer that question. Would you like to answer?
Dr. Unnikrishnan, could you kindly give the answer?
Can you just repeat the question?
The question is that the SpaceX has completely redesigned the space suites, unlike the age-old NASA design. How is your space suite designs?
Yes, SpaceX definitely has the advantage of they are not starting.
I think maybe some connection problem there. Again,
Some 6 or 7 people can go to move.
okay.
But see, when we design a vehicle, we also need to look at what launch vehicle you have. So right now, our launch vehicle is Mark 3. Mark 3 can take only 9 or 10 tons to low Earth orbit. So we have configured a vehicle which is modular in design, which can take 3 people to low Earth orbit. But with there are plans to augment the launch vehicle capability of Mark 3. When we augment the launch vehicle capability, we can add another module and then make it a longer duration mission or with more persons with capable to launch more humans.
Okay, the next question is that the role of satellite communication is digital and remote medical consultations. Dr. Rakesh, can you please?
Yeah. The telemedicine is something that was started by our INSAT series of satellites by providing connectivity to various hospitals and to rural community. But subsequently, this has been taken over by the terrestrial sector because that is much cheaper to communicate, and it is also extending to many areas. I would assume that once the rural connectivity using the new LEO satellite constellation that is coming in, which will give high bandwidth connectivity and low latency, it will lead to probably a scenario where you can have a live operation of consultation between a major hospital and a rural area through a primary health center, for example. And this is something that is very possible with the new technologies that are coming in. So that will be a revolution that will happen probably in the telemedicine area using satellite communication.
Okay, next question goes to Dr. Unnikrishnan. Since we saw about the importance of spacesuit in space mission, how far is the spacesuit self-healing, and what material you are currently using in recent space mission? What materials you were using for the space mission for the suit? Yeah.
It's not a very easy answer because there are different types of materials. You look at the internal, that is inside the crew module, it is mostly driven by safety considerations, like it should not create any flammability, it should be flame proof, but at the same time it should not give out any toxic gas when it is subjected to vacuum. At the same time, it should be lightweight. There are so many other considerations.
That's nice.
Then when you look at the external, the thermal protection or the structure or other things, we are using composite, we are using aluminum, we are using our own special lightweight thermal protection system derived from sand. So if you use silica, so that's the systems. Then we make it lighter and lighter by adding phenolic micro balloon and then make our own system. So there are so many systems, and there will be some special paints to reduce the emissivity so that the thermal loads can be managed. And if you look at the parachute system, it is made out of altogether different material like nylon sheets. It has got the rigging lines are made of so different aspects. I think it's a material is by itself is another branch of engineering where different types of materials we are using. The flight suit is another entity by itself.
Okay, I'll take one more question. What steps are taken to avoid special radiations from interfering with the satellite electronics?
Yeah, this that is something which we right from the beginning we take care of it by proper selection of the frequency and the separation of frequencies. That itself will ensure that the electromagnetic interference is less. Secondly, the EMI or electromagnetic interaction is one part of our testing, which we do testing and then ensure that the interaction for the electronics as well as for the other aspects of the functioning of other avionic systems are not affected by electromagnetic interaction. Then one more aspect is when humans are there, there could be static electricity related issues because human human body generates static electricity, and there could be issues because of that. So all these aspects, basically the potential of the entire capsule is maintained at one level, and all the systems are connected to that, whereby the potential is kept at the same, whereas all other EMI related issues are addressed by design as well as testing.
Okay, so then I'm coming to a few. I have some question because I got from the chat box. First, for Dr. Rakesh, through satellite, can we identify zone for the carbon emission and greenhouse gas?
For satellites, using satellites, is it? In remote sensing unit?
By satellite imaging or something like
that? Yeah, I think there are many programs for this. I think many startups are using radio occultation methodology to detect the emissions. I think, in India also, I think as far as aerosols is concerned, there are many applications already, and still many applications are being developed. So this is an evolving area. Already many applications are available also. So definitely yes, yeah.
Okay. Now, Dr. Unnikrishnan, I have a couple of questions for you.
Yeah.
For the thermal protection system, for the re-entry, the temperature 2000 is for how long you require? 15 minutes, 20 minutes, or more than
The
that?
entire re-entry program, entire re-entry mission is for about 40 minutes. Out of this peak heat flux is only for hardly for 30 to 40 seconds.
Mm-hmm. And what impact strength you require? What's the impact strength you require to protect? It will be a...
No, see it is going to experience the aerodynamic shear. And the impact is coming at the when it is impacting onto sea. That is the time it is experiencing maximum deceleration or acceleration. By that time, its function is over. Whereas the aerodynamic shear is not very significant when the peak heat flux is happening. So what we do internal test in simulated internal conditions are created, and the small scale down models are made, and then the same flow will be passed over the scale down bodies, and you measure all the shear forces and other things, and ensure that the thermal protection system is, the bond strength is more than that. So we have adequate margin for that.
So are you going with the silicon carbide and zirconium diboride for that thermal protection?
So right now we are using the concept of ablation, where it is self-sacrificing and then protecting the inner, because that is such capsules are not reusable one. If you are talking about reusable space shuttle, then you go for exotic thermal protection system. Here we want a very robust system where we are using carbon phenolic, where the heat flux is high, and then silica phenolic, where the heat flux is low.
Okay.
It is totally indigenously developed by Vikram Center, and as I was showing, it was demonstrated and flight proven in CARE mission.
Okay, and then I have next question: the radiation test. No, the radiation test that you do in the space, or you go the nuclear radiation in the IGCAR or BARC and make a simulation of that.
For radiation, we have a MOU with
IGCAR,
BARC, BARC.
Okay,
and also the Defense DLJ, Defense Institute DLJ. They also make. They have the radiation measurements. And in our URSC or the Bangalore Center, there is a space astronomy group. They are also working on that. So we are trying to make a model whether the space weather can be, some knowledge about the space weather parameters. And when the radiation is impinging on the capsule, what is the type of secondary radiation, how it is affecting, and what is the type of inner field. So this model also we are trying to develop. At the same time, we have measurements, both the spectrum as well as the overall dose measurements in the unmanned flight, and we get an idea whether what is the type of threat to the human life. But obviously, when we select the orbit, we go to an orbit and inclination where the radiation is usually low.
Very low.
You can see all the human space flights are happening between 300 to 400 kilometers altitude, where the levels are less, unless there is even something called a solar flare or something. Then definitely at that time, they take some medicine and then they manage it.
And I think the space debris, whatever we see now, it's in the LEO or GEO.
Yeah.
Okay. So, and I don't think it will be encountering space debris, the human space flight.
We cannot say. See, the statistics right now is in every 7 years, there will be an impact either on satellite or anything, which was more close to zero some 30, 40 years back. So when you fly with the humans, we cannot, even though that statistically it is very low probability, we cannot take a risk. So you need to definitely have this design in place. So what we do is we take care of that in the design, and then we make specimens, and then there is a test range in TBRL under DRDO, where they can make a projectile which can fly at 2 kilometers per second and 5 kilometers per second. And we impact onto the specimen and see what is the damage it can create. and whether the design is satisfactory or not.
Okay, but because the space debris, I think the velocity is 8 kilometer to 15 kilometer. So are you going for that? No, that
No,
more more.
nowhere on globe we can test at 15 kilometers.
That one.
The maximum what we can test at NASA is around 6 to 7 kilometers per second.
Okay.
So once we have some data points, definitely we can extrapolate and then see the effect.
Okay, and from the medical point of view, because actually one of my colleagues is working in NASA MSFC, and for the microgravity, will there any hormonal change or the behavioral change once they come back to the orbit, the astronaut?
Okay, that is a very difficult question. I am first of all, it all depends upon the mission duration. Right now, we are all talking about this for us. We are not expecting much of a change in the astronaut because of subjecting to 4 or 5 days. But those who are staying in space station for extended period of time, like 4 months, 5 months, 6 months, definitely these are all areas that are being studied. I don't know whether any material is available in open literature, because my interest is not in that area. So probably these are we need to start such studies in our country. Probably we are the right people to initiate these activities. We can give you all support.
They actually require the doctors.
I was telling the doctors community, they can definitely see, the IBMB in Russia, which is more than 100 years old. It's the very oldest bioastronautical research center in Russia. So many doctors are working on so many, and they are proposing so many experiments. So definitely, I think this human spaceflight program will trigger, and so many doctors also will come.
Medical doctors.
These new areas definitely will emerge, and it becomes, the topic in academics. Like that, we need to start many areas so that when we embark on longer duration mission, we will have questions from our own academia. Answers.
No, particularly if we cross to GEO. Okay, maybe in near future, maybe around say 50-20 years of time, then you require to give all the answers of this.
Yeah. Then that is a totally different ball game. You cannot carry all the resources from ground, because you cannot carry water and all for such long duration. So you need to think of space agriculture. You produce whatever you want. So it's a totally different game, unless you invent some propulsion which can take you in a few days to Mars. Like now it takes around 9 to 10 months.
Okay.
So it's a fiction.
Okay. And my last question. So when do we expect to get the first human mission practically in the orbit? Another 5-6 years time?
For us, no. See, the next year, and we will have the first unmanned mission.
Okay.
And then year after that, the second unmanned mission. So we are targeting to have the first manned mission by end of 2023.
2023. Okay. And you know that in India, everyone having a very high regard from the ISRO scientists, because their contribution is visible. Okay. And we are really happy. And I think now we should have more interactions, not be online, maybe offline also.
Yeah.
For the young students,
Right. Offline, the dimension is different.
Yeah. Okay. Anyway, I got few more questions. Like somebody has put that one, the role of machine and deep learning in satellite image processing. Maybe that question goes to Dr. Rakesh.
So this is something that you can evolving. Of course, there are many remote sensing companies who use this machine learning to produce the product itself automatically. And this is an evolving field, and the analytics to detect the kind of objects that the satellite is seeing, etc., are of importance for this from the security point of view. And today, you can see many new companies who are coming up in the remote sensing, using these technologies to see that the human labor required for processing the imagery is reduced to a great deal. So this is the time, this is the era in which these technologies assume a lot of importance.
And I think Dr. Rakesh, you mentioned about the drone, no, that one for the vigilance purpose. I think I see the video, no, that our that Mr. From our Mr. Girish from our department, he has made the drone from the waist.
Correct. Yeah.
And you can raise him by anything. I sent your message to him. Maybe he is also looking. He's also observing this presentation today. Okay. And also, like ultimately, during the manufacturing of this, how much waste you generate?
How much?
Waste material you generate.
In what?
Maybe for the satellites, for the unmanned, for the manned mission. Like we have different materials, no, like aluminum, titanium, composite, so many things. During the manufacturing, how much waste we generate?
There is no estimate, Shantanu,
no estimate of that.
Actually, yeah.
No, that you can send to us. We can make the drone out of it.
Okay. Understood. Okay, good.
Now NL is sending to us, NL HL.
Yeah.
Whatever the aircraft structure, they're sending to us.
You can directly involve with these manufacturers, I think. Yeah.
Okay, fine.
That is the best way to do that.
I think we are almost done. I think more than 2 hours.
Oh.
How the time passes, no one knows.
Yeah.
So now I request Dr. Parthasarathi Bhattacharya to give the vote of thanks. I think everyone got the very, very overwhelming knowledge, and we can really think for that, collective technology for the country, for our Indian space mission, and each and everyone will be excited to see this first mission to become successful. Thank you from my side. Yeah, Dr. Parthasarathi, please take the phone.
Thank you. It's been a mind-blowing session, and I've never come across such a discourse. It's been a lot of imaginations actually prop up in my mind. I feel there is a lot of space for doctor, engineer communications to utilize the newer, technologies to different kinds of medical treatment arena, starting from material to development of other. Treating other issues. We have got endless problems, because human body is like an universe, and we have just started exploring it. We know very little about it, in fact. So I am deeply indebted to Dr. Rakesh and Dr. Unnikrishnan for their wonderful discourse, and of course Dr. Shantanu Bhowmik to chair the session and steer the question answer session so beautifully. And I should also be thankful to my audience and the people who have encouraged us to embark on such kind of small programs. I hope in future we'll have further scope of communications between Dr. Rakesh, Dr. Unnikrishnan, Dr. Bhowmik, and many others, and enrich our experience and learning, and also help others to be encouraged. And only this way we can proceed for an enlightened future. So thank you very much. With folded hands, I again express my heartfelt gratitude to my faculties and my audience.
Thank you very much for the opportunity.
Thank you, sir. Thank you. It's been wonderful, my friend.
We meet in Bangalore.
Sure.
Yes, sure. Huh? Okay.
Yeah.
I'll show some results to you from our end also.
Yeah.
Maybe it will be useful for you.